Mars, with its sparse atmosphere and lack of liquid water, presents an expanse of arid landscapes that challenges our conventional understanding of a habitable environment. Yet it is against this backdrop that the Perseverance and Curiosity rovers have undertaken a mission to scrutinise this desiccated Martian surface with the aim of determining whether this parched landscape might have hosted life. Welcome and join me, the Cosmic Skipper, as we look at the discoveries both rovers have made and whether we have within our grasp hard evidence for Martian life contained within these titanium tubes. Gale Crater, a focal point for Curiosity since its August 6, 2012 landing, epitomises our desire for exploration and understanding. Central to Curiosity's mission was to explore this crater and gauge the habitability of this ancient environment. In this context, habitability denotes an environment that has the potential to sustain life as we know it. Over the past 11 years, Curiosity has been meticulously evaluating conditions such as temperature, water availability and chemical composition to ascertain if they once favoured the emergence of life akin to terrestrial organisms. So what has Curiosity discovered? For years, scientists have believed Mars was once blanketed by vast oceans and intricate river networks. Water, the lifeblood of our own planet, is a cornerstone for life, acting as a catalyst for biochemical reactions and a nurturing medium for vital processes within organisms. To unearth evidence of Mars's watery past would be to strengthen the very foundation of its potential habitability. Curiosity's exploration has not disappointed, as it has unearthed signs of ancient river systems, lake beds and deltas that point firmly towards a watery past. Simple but visual clues such as finding pebbles have hinted at flowing waters which have helped erode them as they tumbled downstream, reminiscent of every stream or river on Earth. This has helped strengthen the case for Mars's watery history, as has the detection of clay minerals and sulfates. These are markers for the existence of water as they tend to form in wet environments, whilst elemental compounds such as sulfur, nitrogen, oxygen and phosphorus, essential ingredients akin to life's building blocks, have also been detected within the crater. In 2021, Curiosity came upon a remarkably preserved bed of ancient mud cracks configured into hexagonal arrangements. To scientists, these patterns hinted a history of wet-dry cycles on early Mars, with environments such as these being conducive for chemical processes to occur and necessary in the development of microbial life. In the context of the origin of microbial life, these kinds of environments are thought to have played a key role in concentrating and mixing chemicals in ways that facilitated the formation of simple organic molecules, the building blocks of life here on Earth. It seems then that Curiosity has found certain signatures that point favourably to habitability within the Martian environment. Mars and Earth formed at approximately the same time, with Mars having liquid water around 4.1 to 3.7 billion years ago. Life on Earth emerged some 3.5 to 3.8 billion years ago, which is within the window of Mars having liquid water. The implications of this are enormous. Curiosity has strengthened the case for a habitable environment on Mars, so if the two planets were evolving at the same rate, then life at this time may well have been evolving in the habitable Martian environment at about the same time as it was here on Earth. Enter Perseverance, younger sibling of Curiosity, who landed on Mars on the 18th of February 2021. With a suite of equipment to specifically look for signs of ancient microbial life in its landing area of Jezero crater. This crater is of scientific importance as it is an ancient lake bed and delta. The delta in particular is of interest because deltas on Earth are known to be locations where sediments and organic materials accumulate. The Mars delta could therefore have a high concentration of organic compounds, and so Perseverance has set about taking rock samples in its search for these organic compounds. Using its onboard Sherlock system, which stands for Scanning Habitable Environments, with Raman and luminescence for organics and chemicals, it made a remarkable discovery during 2022. It identified a rich collection of organic compounds believed to be aromatics, which are a type of stable carbon and hydrogen molecules with ring structures. Aromatic compounds are significant because they serve as potential indicators of organic material. The fact the organic matter has been found in sedimentary rock, which here on Earth are known for preserving fossils of ancient life, is significantly important, because Perseverance in essence has found potential biosignatures. However, caution is required, as it is also known that geological processes can also produce organic compounds. As good as the instruments and Perseverance are, we need to complete in-depth analysis to determine what is contained within these samples, and the only way to do that is on Earth, and it just so happens that NASA has what it is calling the Mars Sample Return Campaign. Perseverance has already put the samples into titanium tubes, with NASA intent on sending a lander to the Martian surface and collecting the samples. Launching itself into orbit again, the lander would then return to an orbiter above Mars, and from there the samples would be transported back to Earth for analysis. The current timeline to complete this is within the next 10 years, where sometime thereafter we may well have more of a definitive answer as to whether there is life on Mars. I hope you've enjoyed the video, and if you have, then please consider liking and subscribing. Until next time, I've been the Cosmic Skipper, and thank you for watching.